Hello and welcome to another free code session. My name is Jason Bach and I'm going to continue on with dub sharp stuff. As I said, I'm getting close, but as I've realized how whenever actually treats conversions and single integer values in method calls to things like defer or again, it gets a little squirrely. So I sat down and wrote some notes that I think will get us there. And then once we do this, actually putting in the calls to defer and again should be straightforward, though there's going to be some processing logic for the evaluator because it needs to, and eventually when I build the emitter, as I've noticed, like when you do again and when you do defer, again needs to flag it to say that right flag that I currently do in the evaluator that I currently have, not the one that I've been building for the compiler. And then also defer needs to have like an if check in front of it and then only run the statements after the defer if the defer says that's okay. Okay, so, but we'll get there. This needs to be done first though. So what I realize is, for a second I missed it. Like, how did this all happen in the first place? And so when I was looking through the whatever. I don't even know if I'm going to need the converter after this anymore. But, which is true. I should write that down. Possibly won't need the conversion class after this. Because there really is not that many types and I don't have to worry about that much. So, what I was wondering is how was this even done in the first place? And then I realized, oh, there was this trick. Like, how did the syntax of this actually worked before? And what I've done is basically say, well, if you're doing a call, but what you really are doing is a type symbol lookup based on the identifier of the call, which is actually the name of a type, then you're actually doing a conversion, not a call. I mean, it's a call, but you're really doing a conversion, if that makes sense. And I don't want to do that. I don't want to have those in there. So that's what I'm going to do first is get rid of this, okay? Now, if the argument and parameter types don't match, so we get down to here, and we're going to say, well, I'm expecting a string, but you have an integer. So what do I do? Well, for example, if I have a string, or if I have an integer and I need to just string, it's just toString. If I do a Boolean, then I'm just going to have the rule in here to say, well, as long as from is non-zero, we'll just go with that. And then there's other conversions as well. If I get down to this, something bad happened, and it never should get here, because really I only have 3 main types. Okay, so that should never happen. Now here is where I'm going to do the bound conversion. So I'm still going to keep the bound conversion expression around. So I'm just going to wrap the expression that I got from syntax. Where is it? Argument. Argument is a bound expression. Parameter is a parameter symbol. So the bound conversion expression is currently, where is it being made? It's in the bind conversion expression, which is eventually going to just go away because we don't even need to classify all this stuff. So this is a type, and it's coming in because we're passing in the syntax arguments. These are the bound arguments, though. Right. So what I'm going to do is I'll actually pass in to bound conversion expression a bound expression. That's what's coming from the bound arguments. Correct. And then the expected parameter type, because that's what's actually being done in bind conversion. I believe the type, yeah, it gets reversed. Like the type is actually the type of the argument from the call. So I'm not really sure why it's bind conversion is now doing the type. This is the from type. We're trying to go to this. The go is the, oh, because that's the actual like name of the, okay, yeah. So we need to, okay, I think this will all work. I think I just need to do it. Okay, so do I have everything committed? Yes, I do. Okay, so I'm going to say in bind call, no, not there. Bind call expression. We're going to get rid of this first. Okay, we don't need that. Now we need to do, if the arguments and parameters don't match, now what we need to do here is say, yeah, bound arguments. Bound arguments. What would I want? Because the bound argument is actually is when we're just binding the literal arguments of the syntax. We actually have looked at what the target function is actually going to do. Okay, that's where the function parameters comes in, because that's what we just looked up in here from our built-in functions. Okay, so I don't think I want to make this a immutable array, because what I really want to do is make it just an array. Say new bound expression array, but the size of it is going to be, doesn't matter. I could say your syntax arguments length count, whatever works. Okay, and now the bound arguments, and so here I could just say, oh god, oh, can I just switch that? Can you give me? Oh, you don't. You really don't. That's disappointing. For var I is equal to 0. Maybe it can't because there's an error within all the code. Bound arguments length I plus plus. So now what we want to do in here is say our bound argument is the syntax.arguments at position I. Okay, and then we will say our bound arguments at I is equal to bound. And so we really don't even need this. We can just say I, get rid of that. There. So now we have all of our bound arguments. Okay, so now what we need to do is say, well, wait a minute. One of these might need to actually have a conversion expression around it, because we might need to actually convert it. Okay, so if the argument type, the thing you're going to, is not the from, then what we need to do is say bound arguments of I is equal to a new bound conversion expression, where we pass in, yeah, I don't like the name of these things. I personally want to make this a little bit more explicit. Okay, so we're going to say this is the from expression and the to type. Okay, because I just want to. And so this will be the to type, and this will be the from expression. Okay. And then let's just reorder these here so that's a little bit more to my liking. There we go. That looks a little bit more explicit. I like it. So now here what we say is we take the argument and no. The parameter is a to type. Yes, so we say argument, parameter, type. And Bob's your uncle. We do not report a diagnostic. Actually, who's all calling this? Just me at this point. Okay, so then I can just take that out. So we're just literally wrapping it. That's all we're doing. And arguably, we could do this all in one shot. So what we could say here is var argument is equal to the bound expression of this. Okay, then we get the parameter. If that's that, else Yeah, so we could actually do this. We could say bound argument if that is not equal to that, then we do this. Otherwise, we do argument, and that's it. And it goes away. All right, so what did we just do here? We went, we don't even need this anymore. That goes away. And now bound call expression is taking an immutable array. Yes, but now we can actually do immutable array of bound expression, create builder. Right? Okay, what did I what did I do here before? This is in the binder, yes. So immutable array okay. Create builder bound expression. We didn't actually specify. No, we didn't. Okay, so we can get rid of that. Although, does it take a capacity? I think it does. Yeah. So we know what the capacity should be. It's this. Okay. Now what we can say is bound arguments add that. Of course, we need the semicolon. Boom. Done. And so now we have a bound conversion expression to say, oh, by the way, we have that. Now all we need to do is in the evaluator, okay, which is we get a, somewhere in here has got to be a call expression, okay. And so we have to, yes, we need to actually evaluate the expression for the call arguments. Okay, and that would have to be a string because a print expects a string. Okay, so now an evaluate expression here. What we want to do is say if we find a bound conversion expression, we want to do this. Okay, so I have to also be more consistent with, like, do the actions come on this side or the actions come on that side? Because I don't think I'm consistent here. In fact, let me add a to-do. To-do, make the position of the execution engine actions parameter consistent across all evaluate methods. Okay, I'll get to that later. But an evaluate conversion expression, we first evaluate the expression, we get the value. Okay. Now the only reason we would have had this is because we had determined that we had to do a conversion. Okay. So if the conversion is, let's go back to my notes here. Let's kind of do this in reverse, I think. Let's say if the excuse me. Let's grab the var from type, which is equal to conversion from type. To type? Oh yeah. No, that's the conversion. So, wait a minute. From expression, so literal. No, that's the, from expression is just a bound expression, right? Wait, from, it's a bound expression. Okay, so wait a minute, I'm a little, okay, let's actually just add one more piece here. Let's make this just expression. Okay. I'm going to call that expression. And then we want a type symbol from type. So we need to capture that. And we need to say here, this from type. And then we do that. And then that. This needs to be a type symbol. And so that's just about, no, it's just the expression. Okay, so then here what we need to have is the from type is the argument. Wait a minute. Bind expression comes with a bound expression. Right? Wait, what the? ToType. I think I might have done an inadvertent rename on something that should not have been renamed. That was a bound expression. So if I go here, yeah, it's just type. I don't know how that got to be ToType. Okay, and so maybe it was just overthinking this completely, which is a bound expression should have a type. Yes. Okay. So yes, that was... Oh, that's what's confusing me. Is I can't... Yeah, that's an override. I'm an idiot. Okay. That's fine. We'll just say it's a type. And then... I had to take a little break there. The cabin fever in the house, I think, is striking. So had to handle a little bit of an argument with the kids. So is what it is. All right, so now why is this barking? Huh? Oh, from type. Yeah, we don't need from type anymore. There we go. Okay. So we can get rid of here. Okay, and then what's down here? And bind conversion is just completely going to go away because we don't even need that anymore. Which might break something else. No, it doesn't because we took that away. Okay, so now back to here. Evaluate conversion expression. Okay, so the from type is type. There we go. Var ToType is equal to conversion to type. Okay, so that's what we went from. Okay, now from this point, I think I should be able to make more sense. Okay, so from type equals type symbol. What do I have here? Integer. Okay. If ToType is equal to type symbol string, then I simply just do return value ToString. Simple. What would be values? ToString the frickin' thing. There was a debate on this. I remember when they were trying to figure out how to mark up all the BCL methods. This is one of them. And I remember them going with the decision to say that ToString, the string coming out of it, they could not mark as being non-nullable, which I think they probably spent far more time on that than I could ever imagine, but that still feels alien to me. Because I'm like, why would a ToString? I think even the documentation says you should not return a null from a ToString. But for whatever reasons, they decided not to do that. So, yes, else if ToType is equal to Boolean then we return big integer of value not equal to big integer 0. There. And that should return, in this case, a Boolean. Okay. Else, now here is where, if we ever get into this case, it's something I don't expect right now. So I want to be explicit and say, and I could probably clean all this up at some point, but we're just going to go with the explicit if s, blah, blah, blah. Okay. Else if from type is equal to a type symbol of a string. And granted, these may all be a little unsafe-ish, but this is not the best language in the world. So if we have an integer here, so if we need to get to an integer, then we will just do a return big integer dot parse of casting whatever the value was, which would be a string. And if that fails, too bad. If we want to go to a Boolean, we say return bool dot parse of whatever that value should be. Unexpected type. Yep. Else if, this is where we'd say Boolean so if we want to go from a Boolean to an integer, we would say if the bool of the value is, if that is true, then we return big integer of 1, otherwise we do big integer of 0. Otherwise, if it's a string, we just simply do a value to string. Yes! Okay, so now what we need to do is get rid of all this. It's a little verbose, but it works, okay? I believe. So now, with all that done, let's see if it builds first. Now let's see what happens. So if I say 1 print of random of 42, it works. Whereas before I needed to say string. Okay, and so 1 print of hello plus this I bet won't. Yeah, because I need to still I did all that work for something. So how do you actually do that? I always forget this stuff. Yeah, arguably if you did this, sorry, go back to here. If you did that, why would you literally do that? You know, if I say 1 print hello plus, oops, I can't type, plus random of 10, now I said run, yeah, it doesn't know how to actually convert that. So how would you do that? This is also like, it isn't, this is correct, it's not defined for that, but if I want it to be defined for that, what that would really do is just do a ToString on random. Or if I did the other way around. If I did the, well, yeah, then which one has precedence? If that makes sense. Like if I had string and integer for the binary operator, if they're mismatch, well, what do you try to convert to what? And that's where this starts getting really squirrely. So I'm wondering if, crap. So, this is the thought time where I need to cut this out. If I look at the example that they have, because I think this does come up with like 99 bottles of beer. Yeah, they say print that plus that. And there's no conversion there at all. So, like, which one do you take? If the argument of what you're trying to take is that type, then things that are in the binary expressions that aren't of that type need to be converted to that type using a bound conversion expression. So I think what I also need to do is take away the checks on the adds, because all you can do is just say, well, I'm trying to add a string and an integer. But am I trying to say I want to convert the string to an integer and add the two numbers together? Or am I trying to take two strings and concatenate them? You know, because, and this is starting to feel very JavaScript-y-ish, which I absolutely hate, but this is the language that we are given, which is obviously they don't, the type of the argument determines the values for all the, for really everything that's coming into it. They need to know what the target type is and then convert themselves accordingly. That's going to be another episode. I keep feeling like I make progress and then I back up again. It is what it is, but I think that's correct, because we don't have to worry about, the only assignment we really need to care about is assigning to the argument of a function, and that will determine the type that needs to come out of all the expressions from within it. So if something within doesn't actually evaluate to that, then they need to actually be... so I'm wondering, I think what I need to do is remove all... You know what, wait. Let me just get the notes down and then I'm going to stop the episode. So if I said 1 print hello plus random of 10, and I said run, this error needs to be removed. You can't determine if that's an error. The conversion type needs to be based on what it's being assigned to in a method call. Okay. Now, here's the thing. All these are method calls, essentially. Even the syntax of something like 1, 2, 3. That's actually a update line count onto with 3 or whatever that is. I think if I go to this, yeah, update count. Okay, so that's still a thing. And so what happens if I would do something like 2 plus 3? Okay. Well, what you're trying to assign this binary expression to is this. What you really want to do is that. Okay, because the thing that's getting assigned to is a big integer. Okay, so what you need to then is go up and say, well, I am a I am a big integer. So if you do not have a big integer, then all the things within it need to have conversions to go to a big integer, and then it will just express itself correctly. So therefore, we need some mechanism in the binder to look at the expression for a parameter recursively and add conversion expressions for those places that don't match the right conversion. If that makes sense. And this we have to be careful here, because I could also do something like 2 plus the number of lines, the number of how many lines we have for 3 plus 4. Okay. So what I need to make sure is that this in here comes out correctly. Okay. As being 7, and then the number comes out as a number. That would be fine by those two being added. And then, now of course, what would happen if I said 1, print that? No, don't save that. If I said print that, well, I don't want to necessarily make some, this determines what the, so if they match, if those match, you do those. So if the binary expression types on either side match, you just do that. Though the resultant value may need a conversion. Okay, so this you would still do like 3 plus 4. Well, what does that need to be converted to? What is it being assigned to? This could get really messy. I really need to think about this. So this would arguably be converted to a 7. You get the line, whatever that number is, plus 2, you get 3. But then you want to print a number 3, you literally get 3. You wouldn't want to add like 2 as a string plus whatever the value of n coming out is as a string and concatenate those together. That wouldn't make sense to me logically. Okay, so yeah, only if the two things on the sides don't match. Then you need to figure out what the context of it. In this case, the context is I'm actually passing in an integer, big integer. So I have to this needs to be converted to do that. Okay, so I'm already over time. Maybe I'll get to this tonight or tomorrow or something like that, and add this stuff in. It's progress. It's making progress, but it's this stuff is important because I got to get this right before I can add in defer and again. But once I do that, I think, I can still keep seeing the light. I can still keep seeing the light at the end of the tunnel, so to speak. because I think that's the only two things I would need to do for get sent there defer. Again, I have input output, I have N and U, I've got all that. So I think I'm really close. So I'm going to stop for now. Thank you all for watching. Leave comments and questions below. See you in the next episode.